Hi, I'm Miss Roger, and welcome back to Core Concepts in Algebra 2. Today's lesson is on graphing trigonometric functions. The Massachusetts curriculum frameworks for mathematics are tied to this lesson. F-TF, trigonometric functions, number 5, and F-IF, functions interpreting functions, number 4 and number 7. Let's take a look at today's lesson objectives. To connect the unit circle to graphs of trigonometric functions, to sketch one period of the sine curve, to sketch one period of the cosine curve, to sketch one period of the tangent curve, and to identify key features of trigonometric graphs. Let's take a look at some properties of the sine and cosine graphs. The following equations are standard form of sine and cosine. We're going to use both of these when we start graphing. So let's think about what the amplitude is for sine and cosine. The amplitude is a key feature of both of these graphs. The amplitude of y equals a sine of x and y equals a cosine of x represents half the distance between the maximum and minimum values of the function and is given by the absolute value of a. And we're thinking about the absolute value of a in both of those two equations. The period of sine and cosine functions is going to be 2 pi over b. And we're going to get our b value, again, by both of our standard form equations. These are both two key aspects when graphing sine and cosine. Let's take a look at our sine curve. We're going to build our sine curve using what we know about the unit circle. So I've set some of the stuff up here, and I have specifically set up our x and y table, which is going to help us transition from the unit circle to our sketch. So I'm thinking about when the value of sine of x for these various angles. So our x is denoting our angle, and our y is saying what is sine of that angle. So if we see here, these are the ordered pairs that we built last time that correspond to each of these angles. And remember, we're using radians here. So when I think to myself, what is the sine of 0? Remember, the sine is always the y value. So our sine is going to be 0. Now I'm saying to myself, what is the sine of pi over 2? The sine of 90 degrees is going to be 1. What is the sine of pi? What is the sine of 180 degrees? It's going to be 0. What is the sine of 3 pi over 2? -1. And lastly, what's the sine of 2 pi? It's going to be 0. So this is something that we had talked about before with our unit circle, but now we're going to make the transition from our unit circle to our sketch. So I've already started to break it down for us. Our x, which corresponds to the angle, goes here on our x-axis, and our y, which corresponds to y equals sine of x, I've broken down here. Notice that my two scales are different. This is pretty typical. And I've gone kind of by every 4, and for this, I've gone by every 4, but you can kind of split it up however you'd like, and we'll talk about that tomorrow during class. So let's think about this. This is my angle. This is my y equals sine of x. Sine of 0 is 0. So this is my angle, and I'm going to be here. My angle is pi over 2, and y equals sine of x is 1. So I'm going to be able to plot my point there. My angle is pi. Y equals sine of x of pi is 0, so I'm going to plot this point here. And I'm going to keep going. This goes with -1 from our table that we just built. And sine of 2x is 0, so we're going to go here. This is how we ultimately can build our sketch. So now we can do that. We can connect all of these . So now we have our sine curve, which you can ultimately build by taking all the plotted points and connecting them with a smooth curve. This is one period of our sine curve. So let's start to think about some of the key features of our sine curve and our sine graph. So we want to think about the domain. The domain thinks about the x values. So I can continue this curve to infinity in both directions. So I can think about the domain as negative infinity to positive infinity, or all real numbers, okay? Because this can keep going on and keep going. Our range. When we think about our range, we think about our y. So what is the highest point? What is the lowest point? That's kind of what you want to think about. So our highest point is 1. Our lowest point is -1. So our range is going to be -1 to 1. The sine curve is symmetric about the origin. And if you recall from previous sections, this is because it's an odd function. We have odd functions and even functions. So interestingly, sine is odd. Let's think about our x-intercepts. This is going to be 0, 0. We have pi 0 and 2 pi 0. Our y-intercept, where it crosses the y-axis, is 0, 0, the origin. And our period, this is one full period. So we go from 0 to 2 pi. And if we think about the last slide, I talked about the period. The period is always 2 pi over b. So here, our b value is just 1, so we have 2 pi. Our maximum points, this ordered pair, is going to be pi over 2, comma, 1. Our minimum point, our lowest point on the graph, is going to be 3 pi over 2, comma, -1. And our amplitude, this is going to be our distance from here to here. So we have a distance of 1. And this is also the absolute value of a. And for our sine of x graph, this is the absolute value of 1, so our amplitude is 1. The amplitude is always going to be positive. So this is the foundation for our sine curve, and we're going to use this to build other sine graphs. Let's take a look at our cosine curve now that we've graphed our sine graph. So again, if we think about the unit circle and how we're going to transition to our sketch, we want to think about the value of cosine of x. And again, we're going to use the same exact angles. These are the ordered pairs that correspond to each. Cosine, remember, is our x value. So cosine of 0 is 1. Cosine of pi over 2 is 0. Cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. So now, again, we're going to split up our x-axis with each of the angles. And we're going to make it equidistant between each of those. And we're going to think about how we're going to plot this and what this sketch is going to look like. So this is our y equals cosine of x for our y-axis, and on our x-axis we have our angle. So let's take a look at the angle 0. The angle 0 goes with the cosine of x being 1. Pi over 2 goes with 0 for cosine. Pi, cosine of pi is -1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1. And we're just getting this from our table, which is ultimately just from our unit circle. So now I can connect these ordered pairs with a smooth curve. This is my cosine curve. Let's look at some key features of it. Our domain. This is going to be one period of our cosine graph. This curve will continue on and on and on and on to infinity in both directions. So our domain is going to be all reals. Our range is going to be 1 to -1. These are the same for both cosine and sine. Our symmetry, our cosine curve is an even function, which is going to mean that it's symmetric about the y-axis. Let's take a look at our x-intercepts, pi over 2 and 3 pi over 2. Our y-intercept is 1. Our period, again, is 2 pi. And this has to do with 2 pi over b being our definition of what a period is. Our maximum point, where is our maximum points on the graph? We have a maximum here, and we have a maximum here. Our minimum is going to be this point. And our amplitude is again going to be 1. These are the key features in the graph of cosine, y equals cosine of x. Let's look at some properties of our tangent graph. We're going to have vertical asymptotes at x equals pi over 2 plus n pi, where n is an integer. These vertical asymptotes are going to have to be graphed. Our period is going to be the distance between two consecutive asymptotes, which we can find by doing pi over the absolute value of b. We're going to have a midpoint between two consecutive asymptotes, and this midpoint is going to be an x-intercept of the graph. And two consecutive asymptotes can be found by solving these two equations. Bx minus c equals negative pi over 2, and bx minus c equals pi over 2. Thinking about our asymptotes is going to be critical when graphing tangent. Let's take a look at our tangent curve. Remember, tangent of x equals sine of x over cosine of x, which is going to be y over x. So again, when we're transitioning from our unit circle to our sketch, we want to think about various values. So for our tangent graph, we're going to think about 0, pi over 4, pi over 2, pi, 3 pi over 2, and just to kind of see what else is happening, negative pi over 4 and negative pi over 2. These are the ordered pairs that correspond to each angle. And again, remember our x is that angle that we're thinking about in radians. So when I'm thinking about this, I'm trying to figure out when I have y over x. That's going to be our tangent of each angle. So our tangent of 0 is going to be 0 over 1, which is going to just be 0. Our tangent of pi over 4 is going to be radical 2 over 2 over radical 2 over 2. And this is going to simplify down to be a value of 1. Our tangent of pi over 2 is going to be 1 over 0, which is going to be undefined. Remember, we can never divide by 0. So this is going to be something interesting that happens, and we'll talk about that in a moment. Tangent of pi is going to be 0 over negative 1, which is 0. Tangent of 3 pi over 2 is going to be negative 1 over 0, which is again going to be undefined because we're dividing by 0. Negative pi over 4, we're going to find the tangent of it. That's going to give us a value of -1 because negative radical 2 over 2 divided by radical 2 over 2. And tangent of negative pi over 2 is going to be -1 over 0, which is again undefined. So we're going to now use this to transition to our sketch. And when we think about these areas that it's undefined, I should be saying to myself, okay, when is tangent going to be undefined? If I look at sine of x over cosine of x. Tangent of x is going to be undefined when the cosine is 0. Let's see how this information is going to transfer to our actual sketch of y equals tangent of x. I've started to map out our sketch and our graph a little bit right here. And if you notice, the red dashed lines are where we have undefined tangents of those actual angles. And when we have this happening, we have what's called an asymptote. And when we take a look at our sketch, the graph is going to approach each of the asymptotes and get infinitely close, but it's never actually going to touch the asymptote. And again, we're just going to focus on one period. We could do this for a number of periods, but we're just going to focus on one. So negative pi over 4 is going to correspond to -1. Tangent of 0 is 0. And tangent of pi over 4 is 1. So when I sketch this, again, you want to be conscious of your asymptotes. And you want to get as close to your ordered pairs as possible. And remember, this is a sketch. The other thing that we want to consider is how I broke this up. You might be wondering that to yourself. We're always going to have 5 key points. And with our one period, our 2 endpoints of our cycle are going to be our asymptotes. So then I say to myself, how do I get the center point? I can figure out what the middle of negative pi over 2 to pi over 2 is by adding these two values up and dividing by 2, which is going to give me 0. And again, I can find the middle of these two by taking these two values, adding them up, dividing by 2. And the middle of these two, negative pi over 2 and 0, by adding those two values up and dividing that in 2. So you also want to consider those 5 key points when you're building your sketch. We're going to look at additional periods tomorrow, but let's take a look first at our key features. So let's take a look at our key information. Our domain is going to be all of x that can equal pi over 2 plus n pi, because this is where we're going to have asymptotes. So our domain is going to be all reals except this. Our period is going to be pi. Our distance from here to here is a value of pi, because our formula is pi over the absolute value of b, and for this problem our b value is 1. Our symmetry, it's an odd function, which is going to mean it's symmetric about the origin. Our range is all reals, because we're going to infinity in both directions, approaching both asymptotes. And our vertical asymptotes are going to occur at x equals negative pi over 2 and x equals pi over 2, or we can think about this as pi over 2 plus n pi, where n is an integer. Let's take a look at the essential questions after watching sketching sine, cosine, and tangent. How is periodic behavior modeled with trigonometric functions? How are functions in the sine, cosine, and tangent families translated using the parent function? And how can the reciprocal trigonometric functions be evaluated using what we know about sine, cosine, and tangent graphs? Think about these essential questions tonight, and we'll discuss them in more depth during class tomorrow. After watching today's video on graphing sine, cosine, and tangent, try these. For 1 through 3, find the amplitude and the period of the following equations. For 4 and 5, determine the period and the 2 consecutive asymptotes of the following. And 6 and 7, sketch the following graphs. Thanks for joining me in Core Concepts in Algebra 2. I'll see you next time.